First, the objective of the study is to investigate the principle of electrocoagulation method. Second is to investigate the effectiveness of electrocoagulation method in treating palm oil mill effluent, POME wastewater. The third one is to understand the properties of POME wastewater, and the last one is to study the characteristic of the electrocoagulation method. So move on to the next. Malaysia Palm Oil Board the palm oil business in cornerstone in Malaysia's economy, and it is critical in feeding and fueling the world's rising population. The oil palm has reacted strongly in effort in research and technologies development as the most adaptable of prolific oil crop. Growth in the upstream sector has a cascade effect throughout the value chain, and MPOB as the custodian of the Malaysian palm oil industry continues to prioritize R&D and service across the board. Okay, so palm oil mill effluent, POME wastewater, is the wastewater that generated from the oil palm processing industry. It consists of variety of suspended elements. The waste product created during palm oil production consists of empty fruit bunches, as well as less fibrous materials such as palm kernel cake and liquid discharge POME. The wastewater are high in organic materials such as cellulosic waste that include a combination of carbohydrate and oils. Untreated POME discharge has a negative influence in environment. Move on to the next. The characteristic of the POME wastewater are shown in the slide, which is the pH should be from the pH of the POME wastewater is 4.7, while the discharge limit of the POME wastewater is from 5 to 9 pH, and then the oil and grease concentration in the POME wastewater is at 4,000, while the discharge limit is at 50 milligram per liter, and then the BOD of the POME wastewater is 25,000, while the discharge limit is at 100 milligram per liter. COD concentration in the POME wastewater is at 50,000. The total solid in the POME wastewater is at 40,500.
To grasp the concept of coagulation, brief understanding on colloidal chemistry is vital as the wastewater pollutants are generally colloids. Colloids dispersed in a solution remain stable enough to avoid the physical separation processes such as sedimentation, flotation, and general filtration. The stability of the colloids is governed by the balance of two significant forces, which are the repulsive forces at the colloid surface and the van der Waals attraction. When the stone diffuse and electrical double layer EDL of colloids overlap, the attractive van der Waals forces arising from induced or persistent dipoles among dispersed molecules balance out the repulsive force. In contrast to the diffuse layer, the stone layer is made up of a constant surface colloidal charge. The The charges in the suspension have a strong influence on the diffuse layer, resulting in the creation of EDL, an electrical potential barrier that forms between the stern and diffuse layers. The combined effect of these charges layers among the colloids provides a strong repulsive force which keeps the colloid stable. The repulsive force is defined as particle resistance to destabilization, and it is measured by measuring the potential difference between particles. High colloidal stability avoids the formation of flux that can be separated by precipitation or sedimentation. The primary goal of coagulation is to destabilize the colloid surface charge so that the particle can clump together and produce flux that can be easily removed from the water or wastewater. The stability of colloids is determined by the net force from van der Waals attraction and surface charge repulsion as shown in the figure. In the measurement of a zeta potential at the edge of EDL, the particle stability is measured with respect to the bulk solution, providing a direct estimate of the colloidal surface stability while in motion in the solution, and it is the most exact instrument for assessing colloid stability. Colloid stability must be determined in order to monitor and resist the repulsive forces on the colloid surface caused by destabilization. Colloidal destabilization by coagulants is achieved by four mechanisms. First, double layer compression. Second, adsorption or charge neutralization. Third, adsorption or interparticle bridging. And lastly, precipitation. The surface charges in wastewater pollutants are commonly destabilized by adding chemical coagulants and is referred to as chemical coagulation. The coagulants that have been widely used are mainly sulfates and chlorides of Al and Fe for efficient pollutant removal, mainly due to the availability, low cost, and high electrodissolution rates. Also, the increased potential to generate polyvalent ions with high coagulating property makes Al and Fe conventionally accept for the coagulation. The generation of polyvalent ion Al3+, Fe2+, and Fe3+ from the coagulant dissociation in the solution is followed by formation of metal hydroxide. While the metal hydroxide form, the charged hydroxyl ions form complexes with the pollutants present in the solution. Therefore, the repulsive charges on the pollutant surface are destabilized, causing the EDL to compress and collapse, allowing the pollutants to agglomerate and form flux. These flux begin to precipitate and separate from the solution to flotation by rising up on the solution surface or by sedimentation on the influence of gravity, depending on the type of size of the flux produced. By employing CC and flocculation, it is possible to achieve notable results in wastewater treatment. It is achieved 98% removal of COD and 99% of turbidity, which is remarkable with CC flocculation process. However, the process is not feasible for large-scale operation of wastewater treatment with extensive chemical requirement. The major disadvantage of CC is secondary contamination resulting from chemical addition. Additional separation steps are mandatory to remove the harsh chemicals from the final treated water in CC, making the downstream process more complex. Therefore, the emerging technology of electrochemical coagulation with negligible chemical input becomes more appealing.
Hi, my name is Muhammad Zafir Atman bin Muhammad, and I want to explain about the electrocoagulation. The electrocoagulation is one of the various wastewater treatment processes available. It is a straightforward and effective technology. Electrocoagulation is a revolutionary wastewater treatment approach that combines the function and advantage of traditional method in water and wastewater treatment. The hydrogen gas is also generated during the process, which help the flocculated particle float to the water stock. The electrolytic hydrogens produce almost no pollution. Electrocoagulation is a cost-effective, environmentally friendly procedure since it is portable and only require a small amount of room to operate. This approach relied only on a small and compact reactor to produce no secondary pollutant. It is reported that the flocks produce more in these techniques. Aside from that, less bound water is present and no chemical treatment is necessary. For the benefits of electrocoagulation process, EC is involved at less equipment and is easy to work. EC requires low investment, maintenance, energy and treatment costs. EC also treat the wastewater furnish pleasant, odorless, clear and colorless water. EC is also a low sludge producing process. EC generated sludge is mainly composed of metallic oxide or hydroxide. The reuse of EC produced effluent contributed to a lesser water recovery cost. For the disadvantages of electrocoagulation process, the sacrificial anodes are dissolved into solution due to the oxidation and need to be replaced at regular interval. Conductivity of the wastewater suspension must be high. The third one is the viscosity of hydroxide may be likely to solubilize in some cases. The electricity may be not easily available and expensive in some area. And the last one is the efficiency of the electrocoagulation unit decrease due to an impervious oxide film shed on the cathode. For the next part is mechanism of EC reactor. This is a diagram of a bench scale EC reactor. Electrochemically produced metal cation Fe3+ or Al3+ will react spontaneously and produce the corresponding hydroxide and or polyhydroxides according to complex precipitation kinetics. Many monomeric species of Al3+ such as AlOH2+, AlOH2+, and AlOH4+, 4-, and polymeric species such as Al6OH15 3+. Similarly, ferric ions species such as FeOH2+ and FeH2O6 transform into FeOH3. This insoluble FeOH3 and AlOH3 remain in the aqueous medium and destabilize contaminant by completion or electrostatic attraction followed by coagulation. The formulation of this complex is highly pH dependent. The stabilization of contaminants mainly occurs through two distinct mechanisms. Thank you.
Last but not least, as the conclusion, electrocoagulation is the revolutionary wastewater treatment approach that combines the function and advantage of traditional method in water and wastewater treatment such as coagulation, flotation and electrochemistry. In the treatment of palm oil mill wastewater, electrocoagulation is an effective approach. So that is all from our group. Thank you.